Hello and welcome to the Smart ESP project. In this video, I would like to show you how to assemble an actuator by yourself. For those who don't know, an actuator or a linear drive is a useful mechanical device that is often used in home automation. For example, it can be used to open a window in a greenhouse or a door in a chicken coop. Its operation is based on the linear movement of the rod back and forth. This is achieved by rotating a screw with a thread on which a nut is located. Thus, rotary motion is converted into translational motion. So, let's take a look at the components we will need for this. First of all, as mentioned before, we will need a steel trapezoidal screw with a brass nut. It is usually used for building 3D printers and has proven to be quite reliable. You can choose its specifications according to your preference. I have chosen a length of 300 mm and a diameter of 8 mm, with a thread pitch of 2 mm. Of course, we will also need a motor that will rotate this screw. Here, an important factor to consider is what you plan to move with this actuator. In my case, I don't require heavy loads, so I have chosen a motor that is not too powerful and comes with a gearbox. Here is the motor itself, and on top of it is the gearbox. The motor rotates at a speed of over 10,000 revolutions per minute, which is a lot, and has a weak torque. However, thanks to the gearbox, we can reduce the rotational speed and increase the torque. For example, I have chosen the JGA 25-370 model. It will have a low rotational speed of up to 30 revolutions per minute and a high torque of 4 kilograms per centimeter. Next, I need to connect the gearbox shaft with my screw. To do this, I will need a coupling with two different diameters of 4 mm and 8 mm. Any coupling can be used, either rigid or flexible. I used a flexible coupling, like this one. This should be enough to start assembling the mechanism, but we will also need a casing for it. I suggest this option, which consists of the following elements. First, a platform to which the motor with gearbox is attached using two screws. The platform is inserted into a casing between 4 supports. Then, a cover is screwed on with 6 screws. On top, a screw holder is installed like this. It is best to fix it with glue. Finally, there is the rod itself, which consists of 2 parts. The brass nut is inserted into the first part and fixed with 4 screws. The second part of the rod has a bracket and is glued to the first part. Here's what the entire structure looks like when assembled. 2 brackets for M6 bolts are located at the top and bottom. Thanks to the rotation of the motor, the nut moves along the screw and extends or retracts the rod. To protect the screw, it can be lubricated with grease and covered with a sleeve. For example, I use a heat insulator for polypropylene pipes. Now let's talk about some additional nuances when assembling the actuator. Let's start with the installation of the coupling. After the motor is attached to the platform, the coupling is mounted on its shaft. However, there is a nuance here in that there will be a longitudinal load on the actuator rod, which is likely to shift the coupling off the motor shaft. Therefore, it would be good to place 2 plastic washers above and below the coupling. In this case, the coupling will be able to slide gently if it hits one side of the casing. The second nuance is that the actuator should be equipped with a revolution counter, which will allow us to determine the current position of the rod. The easiest way to do this is with a Hall effect sensor A3144. This is what it looks like. This sensor reacts to a magnetic field, which can be generated by a miniature neodymium magnet like this one. I suggest placing this magnet on the sleeve. It is even better to place 2 magnets on opposite sides. Then our sensor will trigger every half turn, which will increase the accuracy. They can be fixed with tape or glue. Don't forget to check the magnets before installation. They have polarity, and the plus sign should be facing the sensor. Now you can solder the wires to the sensor and glue it to the special groove on the motor platform. Make sure that the sensor is at the same level as the magnet and there is a gap of several millimeters between them. Carefully place the platform in its place. Next, you need to install the screw. Insert it through the hole and tighten the screws on the coupling. To rotate the sleeve, you may need to briefly apply power to the motor. The structure is ready, now you need to connect the wires. This can be done in any convenient way. We did not make a hole in the casing, but you can drill it wherever you find it convenient. Finally, install the cover and glue the top screw holder. Assembly is complete. I need to tell you about the travel limiters. They are necessary to ensure that the rod moves only within specified maximum or minimum limits. Otherwise, this can lead to damage to both the actuator itself and the window or door it opens. I suggest using travel limiters outside of the actuator rather than inside. This can be a push-button switch, which is placed on the window or window opening. Let's see how it works. If you remove the cover, you can see a limit switch inside that opens the contacts when pressed. That is, if it is connected in series with the motor circuit, when the window hits the frame and presses the switch, it will break the circuit and stop the motor. However, this is not all. When we reverse the polarity of the motor power supply, it should start opening the window, but if the circuit is broken, the motor will not turn on. To fix this situation, we need to add a diode that allows current to pass only in one direction. I soldered a N4007 diode directly to the switch. It fits perfectly into the casing. Now, when the switch opens the circuit, I will be able to switch the polarity of the voltage on the motor, i.e., reverse its direction. Then the circuit will be restored through the diode. Here's how the maximum limit switch works, and the minimum limit switch is assembled in a similar way, only the polarity of the diode is changed. The actuator is ready and can be tested. For example, I want to connect it to a smart chicken coop project, where its task will be to open and close the door for automating bird roaming. That's how it works. In the extreme positions, I have installed limit switches that will prevent anything from breaking. I would like to mention that you can find 3D models of the actuator housing and limit switches on the smartesp.net website. The link will be in the description below the video.